What's up, guys and dolls? I'm your host, Coolio Von Cooliette, and I am here to bring you cool math. This will help you in your careers in the mathematics field, and I will teach you to be a top mathematician. Today's subject: cosecant. And would I say cosecants? Because I know you little Johnny over there, sitting there eating your apple pie. You were thinking, oh, maybe it's cosecants? I don't know, maybe just regular cosecants? What cosecants is Coolio Von Cooliette talking about? Well, little Johnny's sitting there in the corner eating his apple pie. I'm talking about graphing the function of cosecant. So, before you get started on actually graphing a cosecant, you need to know how to do a sine graph. Now, you probably already learned your sine graph, so it mustn't be very difficult for you to learn. But as a quick review, you need to know your asymptotes, and your asymptotes are where the graph will go up or down to. At this rate, you should all know about the period, which is essentially where the graph will end. In most cases it does, so yeah. Anyway, for to solve your period right here, in case if you didn't know, it's 2 pi over b, and you see that on the equation over there? That's where you get the b from. B can be any number, of course, so yeah, don't stress. And here are your equations. Y equals a times sine times b and x. Or, in another case, it's d plus a sine multiplied by bx minus c. The c in an equation can cause a horizontal shift, and the d in an equation can cause a vertical shift. Now, I will show you some examples. So we're going to start doing a sine equation just to get you started. In the equation I have right down here is y equals 2 sine multiplied by 2x. The a is 2, therefore the absolute value of 2 is 2. B is also 2. Note that it is beside the x, that's where normally the b would be, and yeah, not even normally, just always there. I don't even tell you different, girl. The period, which I'm going to explain how to do right now, is pi. So, here we go. Okay. So, since the b is 2, okay, see that right there? Yeah. So you stick the 2 under 2 pi, and that would equal 1. Therefore, well, obviously 1 pi would equal 1 pi. Therefore, of course, that would translate into pi. So, I'm going to graph it. Now we're graphing our points. Our points you see right there in the bottom corner. Pi multiplied by 1/4 equals pi over 4. Pi multiplied by 1/2 is half of pi. Pi multiplied by 3/4 is 3 pi over 4. Now, we're gonna get to business and we're gonna graph. Okay, so as our equation says, it's 2 sine multiplied by 2x. So you go up, this is where your asymptotes are going to be. Now, in a sine equation, it is, and let me just make sure, up, down, down, up. So we're gonna go up 2, down 2, and down 2, up 2. That is essentially what a sine graph looks like. It looks like a backwards S, so always remember that. Okay, I think we're ready for the big leagues now. So to graph your cosecant function, I already drew the sine function graph. As it says right here, the asymptotes, well, actually no, it isn't the asymptotes. The amplitude is 1. b equals 1, the period is 2 pi, and the points are pi over 2, pi, 3 pi over 2. So to do your cosecant equation, what you're going to do is put a little curve over the other peaks and valleys. Right here and right here. You could add one if you wanted right here too. That is your cosecant equation. Oh, and by the way, asymptotes, what I meant. Well done. And let me change that one, just so I don't mess up with your brains. But the asymptotes are very important here in your cosecant. To go in between wherever your little peaks and valleys go. So, that's all for me, guys and dolls. My cool assistants will be chilling and teaching you math. Cool math, by the way. Stay cool.
Hi, I'm Chris, and I'm going to teach you about math today. As you can see, I'm going to teach you about the cosecant curve. You have y equals 6 cosecant x. To solve this, you need to find your a, which is 6, the amp, which is the absolute value of your a, which equals 6, the b, which comes after the cosecant in between the x, and since there is nothing, it is 1, and your period, which is multiplied 2 pi over your b, and since b is 1, your period will be 2 pi. After that, you want to start with your graph and just draw it up and find your points. Now, to find your points, you need to multiply your period by 1/4, 1/2, and 3/4. From these, you will get pi over 2, pi, and 3 pi over 2. And for your last point, you will always use your period, so you have 2 pi as your last point. Now you want to come to your graph and plot these points. You have pi over 2, pi, 3 pi over 2, and your period 2 pi. Now you're going to come over here, and since your a is 6, you're going to draw. Hold on. Since your a is 6, you're going to start up 6 points and down 6, 4, 5, 6. Now, since the sine curve starts at 0, you want to start at 0 and draw out the sine curve. You go up, down, down, and then up to the middle. Then you want to do it the same way on the opposite side, where you go down, you come up, go up, and then back down to the middle. Now that's your sine graph. The cosine graph you mark at the edges of, at the end of the curves. So here would be your cosecant curve. And when you're done with the problem, you want to erase your sine curve. Didn't do it so pretty, but whatever, you know what I mean. And there you have your cosecant graph.
Okay, so your problem is y equals 4 cosecant x plus pi over 2. The original root of cosecant, you have to remember, is sine. So you would take this as if it were y equals 4 sine x plus pi over 2. So first we have to find the A, the amp, the B, there is a C, and the period. So your A is always before sine, or cosine, or secant, whatever that it gives you there. And the A in this case is 4. The B is always between here, so the B in this case would be 1. The amp is the absolute value of A, which is 4. And your C is always what follows the x. So in this case, it's negative pi over 2 because you have to change the sign that's here. Your period is always 2 pi over b. And in this case, since there's no b, it's only 1, it's 2 pi. So if you have a C, you will only need to have the first and last point in your graph. So if you start the graph at negative pi over 2, you have to add the period, and you get that by doing 2 pi over b, and we saw that the period equals 2 pi. So you add 2 pi to this, and this is 4 because you have to get the common denominator, and this would equal 3 pi over 2. So this equals your last point. So now, graphing it, you start at negative pi over 2, and you end at 3 pi over 2. So you have to remember that the amp was 4, so you go up 4, down 4, just to be sure. Now, graphing the sine curve, it's always goes up, starts at 0, you go up the amplitude, back down to 0, down the amplitude, and back up. Now, since we have a point on the other side and we want to get all the asymptotes, we have to continue this pattern on the other side. So down, up, down. Okay, so since you have that, you have to do your asymptotes now, which is always on the sides of these points. To graph your cosecant curve now, you have to remember that it's a parabola on the peaks and the valleys of your sine graph. So it would be here, 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 and here. So you just make these darker. And those are your cosecant graphs. We have to remember to erase the sine graph, or just make these darker. And there you go. Okay, so your problem is going to be y equals 3 cosecant x. The amplitude equals 3. The b equals 1. And the period for cosecant is 2 pi over b, which is 2 pi over 1 in this case, so it just equals 2 pi. Now for the graph, you're going to place your key points, which range from pi over 2 to 2 pi. So pi over 2, pi, 3 pi over 2, and 2 pi. And place your amplitude, which is 3, -3. Now when you're graphing, you are going to graph as if you were graphing a sine curve first. So you're going to start at 0, then move up to 3, back down to 0, down to -3, and back up to 0. And since you need to place your asymptotes, you're going to elongate the graph, so just do the same graph but move it to the left side, starting at 0, down to -3, up to 0, up to 3, and back down to 0. So now you're going to place your asymptotes, which are the dotted lines, anywhere that there is a change in the curve. So starting from the right side, there would be one over here, one right here, one over here, here, and here. And now to graph, you're going to graph the U's anywhere that there is a peak in the sine curve. So starting from the left side, when there's a peak on the top, you're going to place a U, a regular U, and then when there's a peak on the bottom, upside down U. Anywhere there's a peak. So then when you're done, you would just erase the sine curve, which is the red curve, and that would be your cosecant graph.